So let us have a recap of whatever we have done, students. Okay. So we have seen what is SFD BMD. This was last class. Okay. So here we have seen what is shear force. One side, all the forces. If we take the take the algebraic sum of vertical forces and reaction, to the left it will be our SFD. When you take the algebraic sum of the moments on one side, it is a bending moment, but sign convention is sagging bending moment is positive, hogging bending moment is negative. In case of shear force, one which causes clockwise couple of the two shear forces, it is positive, anti-clockwise couple is negative. Okay, so the effect on the beam is very important. Okay, now we have done some problems, we have gone how to solve a lot of things. Okay, then yesterday we solved very good ones. One of the things was change in shear force is equal to the rate of change of shear force with respect to the length is equal to the loading diagram. So derivative, first derivative with respect to x of the shear force diagram gives the loading diagram. And also to find the difference in the shear force between two sections, what we have to do, we have to integrate the loading diagram along that particular section. That's it. Okay, that's what we got, right? Similar way, in case of bending moment, the rate of change of bending moment or the differentiation of bending moment with respect to span gives the shear force. So these are the two things. Okay, another thing we saw was that's what another thing, this we explained, is it not? Next, if there is a point load, what happens? There is a sudden decrease in the shear force. If there is a point load, that's what we saw. And if there is a point load, this point load does not change, changes the slope of the bending moment diagram, but it does not change the values. There is a continuity, so only the slope is changed by a point load. Another point we saw was when there is a concentrated moment at a point. Okay, what's going to happen? The concentrated couple or a moment at a point induces a sudden change in the bending moment diagram. Okay, now let us put some more points here. Okay, I think one or two points I want to tell you with respect to maxima and minima. These points may be very important. Okay, see now what is happening is, I'll put some more things. Okay, fine. Okay, now what is happening is when you differentiate bending moment, say m is there. Okay, bending moment is some function of x, correct? X is the span of the, it is some function of x. Okay, now dm by dx gives me the shear force. Now if this dm by dx is equal to 0, that means shear force is 0. What about the bending moment? Bending moment m is extreme or extremum, correct? It is either, m is either maxima or minima. What is happening when dm by dx is equal to 0? That means if I have shear force diagram, if something is like this, the shear force diagram is this way, then what is the bending moment diagram? Bending moment diagram can be either this or this, where at this point it is the maximum. Okay, there the slope is going to be 0. Very, very important, students. The slope there is going to be 0. Okay, so this would be the bending moment, either positive or negative, one of the two. Okay, so wherever the shear force diagram is going to 0, that is, then dm by dx will become equal to 0 at v is equal to 0. Okay, similar way, dv by dx, wherever it is going to 0, the load curve is going to become 0. Okay, the load at that point is going to be 0. That has to be understood. It cannot change. dv by dx will become 0 only when load or the q is equal to 0. These things we have to understand. Okay, otherwise it doesn't change much. Okay, done, students? Okay, this one point we will have and then we will go further. Okay, now the fifth question, let us solve. Is it clear, student? Is it seen? Is it small? Are you able to see the question? I hope yes.
Yes, sir.
Yes. In a bending moment diagram of a simply supported beam, discontinuity in the bending moment occurs A. At the point of application of a couple, at the point of application of a concentrated load, at a point where the cross section of beam changes abruptly, at a point where shear force is zero. Where is the thing? Now discontinuity, when you say, don't think that if there is a bending moment like this, say bending moment diagram goes like this, okay, let it go this way and then drop. This is actually discontinuity, students, okay. This one is a discontinuity. Don't think it's a continuous one. No, it's a discontinuity. From here it is dropping down here, that's it. Okay, so now tell me, what does it mean? What's the answer? A is the answer. We have done that yesterday, is it not? When there is a moment which is acted, we have seen a concentrated couple induce an abrupt change in the bending moment diagram. So A is the answer. Very good. Next, what about this, students? The shear force V diagram for a cantilever beam under certain loads applied at a point B and C is shown. The magnitude of applied force B and the magnitude of applied force at C are, which is the answer, students?
So is it A?
Correct, it is A. Others have got it. Why A? Don't pretend that you know. Only if you know, you tell me you know it. Because every aspect has to be known, students, okay? It's not that sometimes you may feel I will solve this question, that is done. No. When you solve the question also, every doubt has to be cleared, okay? Otherwise, tomorrow a question which is unknown will come. At that time, you will feel it difficult because some of the doubts were not clear. Okay, so now here what is happening here is, what is the load over here? See here, it is 200 Newton on the down. So what should be the reaction here? Reaction should be 200 Newton. Easy. If it is 200 Newton there, now what is the force by which this is changing? How is the force which can come? Force is in this direction, observe. Because the force is in this direction, the bending moment has changed. Correct? Is it correct, students? So what is the change? It is 200 and 300 here. Change is 500. So this 500 is the correct one. It's not there anywhere else. So you can directly take that. But then when it comes down, it is down over here. So it is 300 Newton here. That's how you can find it out. Another point over here, students. Because it's a point load, the shear force is constant. Because it is a point load, the shear force is constant. How would be the bending moment? Bending moment would be a straight line, is it not? How can you draw the bending moment for this, students? How will be the bending moment? How will be the bending moment diagram? Just check it out, students, how the bending moment diagram goes. Can you draw the bending moment diagram here? With respect to this, it is 0. As it goes down here, over here, what is the bending moment diagram? Can you check it out, students? Write it down and check out and give me the bending moment diagrams. Take the photograph of your whatever you have written on your notebook and then send it to me, students. Okay, tell me what would be the bending moment diagram of this. Students, you have to send me all the things. Okay, not that I'll be able to see everything, but if I'm able to see some of the things, because in my free time what I will do, I will see all the students whatever they have said. Okay, so in that, if I find a lacuna, if I find somewhere you have missed the concept, I'll correct you, students. I am making it all in one of the folders. I am putting all your responses. So anywhere if I see a lacuna, I will point it out. Okay, so it's not just that you are there, only the classroom is there. It's a continuous one, continuous process. I will just message you that there was some missing point in your understanding, that I will message. So write this down neatly, students, in a this one whenever you have time. There's no urgency, but whenever you have time, write it neatly on a notes book, and please send a photograph to me. Okay, I will put it on a separate folder on your name. Okay, fine. Next, what about this? What's the answer? These are all 1 mark questions, students. Question 7 means 1 mark. Question 15 is 2 marks. This is 2 marks. This is 1 mark question. Yeah. Has anybody solved this question? And attempting is very important, students. Okay.
Sir, 8p by 3.
Wrong answer. Wrong answer. How did you go about?
Sir, I calculated bending moment, maximum bending moment at both the bending moment at both the midsection of both the beams.
Correct. And you equated it, is it not?
Yes, sir.
That's how you have to do. But you have done some mistake in calculation. That's it. Okay. So here, let us take one side. Okay. So what is that happens here? L by 3 is there. So I can say with respect to this point, A, B, C, D, E, let me tell you. Okay. So ME, if I take, that is equal to the bending moment, right? If I take one side, on one side, let us to take, okay. On one side, if you take, or bending moment, let me take it like that, on the bending moment at E. So what I should take, one side I have to take. What is this? E. This side bending moment is what it gives. It gives hogging bending moment, but still it's clockwise. So it is giving minus. So minus P into what is the distance? What is the distance here? From here to here? It is L by 6. Is it not, students? It's L by 6. Is it not? And then over this, what would be the reaction over here? The reaction, because this is P and it is symmetrical and there is no horizontal forces which is there, so this becomes P and P. So it is similar thing. It will be plus P because it induces a sagging bending moment. So plus P into L by 2, correct? Plus P into L by 2. This is the bending moment at E for the first one. What is the bending moment at E? Sorry, bending moment at E for the second one. For the second one, it would be minus P into, here it is L by 4, correct? L by 4, and then plus P because it is the same thing, right? It's the same thing, P into, we have L by 2. Now equate these two, that's it. So when you equate that, sorry, this is P1, I'm sorry. Equate that, this is equal to this, okay? So you say BM E1 is equal to BM E2 and find out P and P1. Please do it, students. Are you still getting 8P by 3? Just check it out. Take time, don't worry. Don't rush into the answers. We will solve some more truss problem also, students, because we should not miss it. Not today, tomorrow we will solve some more truss problems. Because trusses and bending moment, these are something which is common. Okay, solid mechanics, in the solid mechanics XC paper, 2 marks on trusses will be there, 2 marks will be on bending moment diagrams, general. Okay, SFD and BMD. So 4 marks you get easily. And what is the pass mark for XC? It is 24 or 26 last time. So it's very easy, and questions are also easy. These are all XC paper questions. And mostly conceptual. Okay. And XC paper questions are a bit tougher than CE or ME, that I agree. But still it is not tough enough. Okay, you can do it easily. The problem happens because of the big, syllabus, that's it.
Sir, C on.
C is the answer, correct? So answer is C. Very good. Everybody got this? Who did not get this? Simple, right? Okay. Anybody who did not get this? I hope no, because it's direct. Okay. What about this, students? A simply supported beam of span L is subjected to a couple M naught at a distance A from the support A. Among the four options from option 1 to 4, the correct shear force diagram is. What are the loads, students? Try to find out. That also is possible. Another thing is saying that how the moment influences shear force. That can be seen and you can get the answer.
Sir, is it option A?
Very good. It's option A. Others? Now let us understand how to approach this. Now the first point I have to say is that if it is a point load, which is the case here, point load can be moment load or a force load, right? So it's a point load. If there is a point load, shear force is constant, correct? So load Q is a point load, shear force will be constant. What is the bending moment? Bending moment will be linear, one level higher, correct? So now why? Because when you take the differentiation of bending moment, it should come as a shear force. When you differentiate that, it should come as a point load, so it should come 0. Okay, so constant, when you differentiate, it is 0, correct? So here what is happening is, when it is M is equal to linear, okay, M has to be linear, but V is constant. So wherever linear thing is there, linear shear force diagram is there, you can cut that out. That is wrong. Why? It is linear. Okay. Second point, between option 1 and option 2, which is the right answer? Here what is happening is only the bending moment is active. Okay, so when a bending moment load comes, there is no influence on the shear force diagram. Since bending moment does not cause any influence on the shear force diagram, this is wrong, which shows the influence. Only option which is remaining is option 1. Any doubt on this, students? Clear? Fine. Very good. Next one. The beam shown below carries two external moments. The counterclockwise moment of the magnitude 2m acts at point B, and clockwise moment of magnitude m acts as a free end. The beam is fixed at A. The shear force at section close to the fixed end is equal to. It's a 1 mark question, students.
Sir, 0.
Very good. Very good. Now this has to come very fast. Why? Because when there is moment only, and this is a cantilever beam, not a simply supported beam. If it was a simply supported beam, yes, then these supports, roller support or hinged support, cannot give any moments. So they have to give moments in terms of forces. But here cantilever fixed beam can counter this in terms of moments. So the reaction is a moment here. So 2m on this side, m on this side. So what should be the thing? The reaction is moment over here. What about the forces? Forces is not there at all. So since there is no force at all, how can be a shear force? So it is 0. Any doubts here, students? Easy questions. Okay, these are very, very basic questions, easy questions. So you should be able to understand. Okay. Next, what about this? The shear force diagram for a beam AD, which is simply supported at A and D, is shown. The magnitude of the maximum bending moment is dash, rounded off to 3 decimal places. Yes, student, you get the way?
Sir, is it 5.625?
Very good, super. It is 5.625. Good, man. Others? Very, very good, Nitin. See, one of the main thing you have to understand is, see, because this is a direct linear, see, from here to here, it is linear. So since the shear force diagram is linear, how should be the loading diagram? Loading diagram should be straight, is it not? So when loading diagram is straight, one of the things what is asked is the magnitude of the maximum bending moment. What is the bending? Where is the bending moment maximum? Where the shear force is 0. So where is the shear force 0? At 0.75. So what we have to do? We have to check out, it is linear, it is 0.75. So what we have to calculate? We have to calculate what is the bending moment at 0.75. And what is the reaction? If you see, reaction is 15 kilonewton here. Why it is 15 kilonewton here? Because there is a spike here, one reactionary force. But now another point what we have to see is what is the value of this? Correct? What would be the value of this Q loading diagram? This value is equal to the slope of the bending shear force diagram, is it not? What is the slope here? Slope here is given as 15. What is the slope? You can get it. Yes, 15 by m is equal to slope of the shear force diagram. Slope of V can be 15 divided by 0.75. So many Newton per meter, and this comes out to be 20 Newton per meter, students, right? Slope of V comes out to be 20 Newton per meter. So this is 20 Newton per meter. Now it is easy to find out the bending moment with respect to this point, is it not? Where is the equivalent acting? Equivalent acting is over here. What is that? Q into 0.25. So what? 0.75. So what is this? First of all, this is 15 acting over, which is causing a which type of bending moment? Hogging bending moment, right? So it is minus, I will take 15 into 0.75 causes a hogging bending moment, correct? Plus, right? Because no, sorry, sagging bending moment. So it is plus. I'm sorry here. Okay, this is causing a sagging bending moment. So it is plus. I'm sorry, and then minus. We have on this side the distance with the equivalent is 0.75 by 2, or let us calculate how much is the thing. There is Q into 0.75, right? Q is 20. 20 into what is the direction it is causing? It's opposite to this, so it's plus. Sorry, minus. I'm sorry. It's opposite to that. It is causing a hogging bending moment, so minus. 20 into what is the 0.75? This gives the load which is equivalent. Okay, into 0.75 by 2 is the distance between this point and this point, right? It's 0.75 by 2. This is the distance we have to take. Okay, so 0.75 by 2. Oh, I'm sorry. So Yeah, 0.75 by 2 is this distance, correct? This distance is 0.75 by 2, correct? So since that is 0.75 by 2, this comes as like this. So this is the maximum bending moment, which is 5.625. Very easy direct question. Is it not, students? Hogging bending moment, Newton meter. Easy. Any doubts here, students? Anybody who did not understand? You see, it is very easy. Questions are very easy. If you understand the concept, things, everything you will be able to solve. Okay, fine. I think this is small, right? So you are not able to see. Just see your this one, students. What you say? The okay. Let me put it a bit bigger and make it like this. Okay, bit big on this side. I hope now you will be able to see. Now are you able to see, students? A simply supported beam is shown below, is subjected to clockwise moment M at 2 points A and 2 counterclockwise moments 2M and M at point B and C respectively. Which one of the following is the correct bending moment diagram? Tensile at the bottom is positive for the beam. Which is the correct bending moment? Which is the option we can summarily reject, students? Can you tell me? First option
D.
that can be
D you can reject those.
D I can reject. Okay, why? Because yeah, D I
Because
can reject. Yeah, please tell me why I can reject B. D.
because of that concentrated couple at point A.
So concentrated in a couple on point A should induce here, is it not? That's one of the way. Anything here also you can see that there is a yeah, that one thing you can reject. So D is rejected. What about B? B can you reject or not? On what basis can I reject B?
So because of a normal reaction, there will be linear variation of the bending moment.
Exactly. There is a linear variation of the bending moment. So this is gone. So what should happen if it is a point load? It is a point load. If it is a point load, it is a constant variation of the shear force diagram. And it's a linear variation of the bending moment diagram. So since bending moment diagram is given linear, it is not an option. It's given constant, it's not an option. Okay. So it is A or C. What is that?
A only.
A. Very good. We will see others. Others tell me what is the answer, how it is. Others, are you okay with it? Just see it. What are the reactions? Can you calculate the reaction, students? First, calculate the reaction. What is RA and what is RB? Tell me first what are the reactions. RA and RC. I'm sorry, RA, RB, RC. Yeah, students, tell me what is RA and RC. Is RA is equal to, what I got is minus 2m by L, correct? And RC I got it as 2m by L. Am I correct? Am I correct, students? Yes.
I think it should be other way around.
Other way around?
Because if you see the movement diagram, it should increase bending moment.
So?
If you put RA is equal to minus, then it should decrease, right?
Correct. So RA is not proper. Have you seen the reactions properly, students? See whether the reaction what I'm getting is right or wrong. Don't go on that. Okay. Check out the reactions. Whatever I've done is right or wrong. If it is minus, then it should be this one. C should be the answer, is it not? Let us see. Let us see. Whether RA is minus 2m or plus 2m. Tell me, students. I think it's not proper, right? It's m by L. I'm sorry. Correct? Is it? What is the answer? Can you tell me, students? It's not plus also. Let me say sigma ma is equal to 0. Now what happens here? I get with respect to this 2m and m into RC. Correct? So I can say here RC here, if you see 2m and m. So 3m, is it not? So 3m. I'm sorry. So it is.
But one is clockwise now.
Which is clockwise? With respect to this point, okay. I have to take this also. Yes. So it is 2m, and then this one is clockwise. This one is 2m here. Yes. I'll get the same thing. I'm sorry. It's 2m only. Okay. So what I get with respect to ma, if I take 2m minus L into RC is equal to 0. Means I get RC is equal to 2m by L. Is it not, students? So since RC is equal to 2m by L, what is RA? Minus 2m by L, correct? Because sigma f is equal to 0. Correct, students? So that is minus 2m by L, correct? So now how do we go forward? Now if I take the moment with respect to B, what is the moment which is caused? We know it is linear because it's changing, okay? So it's linear. So one of the question is whether we go with this or whether we go with this. So what is happening here? When there is a moment, what type of moment this is causing? This is causing a sagging bending moment. You have seen it is positive. Observe here. It is given positive below. Observe there is a positive below, negative down, upwards. So it is positive being given. So what is the positive bending moment over here? M. Positive bending moment. Correct? That's correct. As we go ahead, It's going to increase. How much does it increase? By what point it increases? It is m into, it is increasing or decreasing? One of the important thing, it's increasing. So when it is increasing, it has to come in this side. It is not this one. This is decreasing. So when you say, I'm sorry, I'm not using the arrow sometimes, okay? This is increasing. This is decreasing. This is increasing. Plus is increasing. Tensile at the bottom is positive moment. Okay, that means this is bottom. See, positive. Okay. So what is happening? It's increasing. So you see this 2m minus L is increasing, students. Is it not? Okay. Till where it is increasing? Till here. After that, what happens? The other side will come. Here, this side, you have 2m here acting on the other side. So it will go down. Then this way. So answer is A, not C. Convinced, students? Convinced? So you have to go to the depth, understand everything onto this. On this, do you have any other doubts, students? Any other doubts which comes to your mind? Please ask. When you ask, even if it is stupid, it's okay.
So for that to happen, RA should be positive, right?
RA, how positive?
Otherwise, it will cause
Otherwise?
hogging movement, sir. If RA is negative, it will cause hogging movement, I guess.
Okay. Now when I say this point, what is the moment which is causing? It's causing like this, is it not? RA. Oh, I'm sorry. Correct. I'm sorry. Wait a minute. This is not the direct, it's minus, is it not? So it's minus, so it should come on this side, correct. So what is the moment it is causing? It's causing hogging only. I'm sorry. So now I think I have to change. Okay. So what is going? It's going as a hogging bending moment, correct. So since it is a hogging bending moment, it is going on this side. What is going to happen? It is going to decrease, correct. It's going to decrease. This is the correct RA. I've done a mistake. Okay. It's going to decrease. And what point it will reach? It will reach the point where m minus 2m by 2. So what will happen is m minus what we will have 2m by L by 2. Correct? This is L by 2. So L, when I say, wait a minute, students. So it is this into L by 2. Correct? So here it should come as, wait a minute. Am I correct on the calculation of this one? It's correct, no? So it is 2m here. Wait a minute, students. Here this is 2m is, this is anti-clockwise. This is anti-clockwise. This is anti-clockwise. So you get 2m is positive, correct? And this LRC is also causing, just a second, student, this L crossed with RC. Okay, RC we have assumed here. It also, yeah, this is positive. I'm sorry. Correct. I'm sorry with the calculation I have done mistake. The calculation mistake is having a minus here instead of plus. So what should happen here? RC should be L into RC is positive. So this will become RC is minus. I'm sorry here. So RC, actual RC comes in this fashion. So if it comes here, RA would be 2m by L and RC is minus 2m by L. Correct. You understood, students, how small mistakes will wreck our answer. Correct. But again, questioning simple things can lead us to the right answer. So what is happening here? This is sagging only. It is increasing. So A is the answer. Correct. So this is not the answer. Easy, students. Any other doubts you have? Let us probe. And keep in mind, gate happens by continuous practice. It doesn't come at once. Don't think that it comes at once. It comes slow and steady. Okay, fine. So this one, students. The beam shown is loaded at a concentrated clockwise moment of 80 kilonewton meter at point B. The bending moment diagram in kilonewton meter is, which is the correct bending moment diagram. I've not seen the answer for it. Let us do it and then see the answer. This has come in 2015 XC, students. Calculate the loads, students, first of all. Should we calculate the reactions or we can guess it just like that? So here, can you tell me which is the thing we can summarily reject at first glance? Which are the options we can directly reject, students? Which are the options? Can you tell me? First C,
C and A.
C and A, very good. C and A can be rejected summarily because there is no abrupt change in the moment, you see, because there is a moment which is acting, so C and A is gone. Now let us consider next one. And both of the directions are the same, you see. So direction how it is changing is the same, B and D. So we cannot we cannot guess by having a different directions, okay. So B and C, or B and D, what is the answer?
D, sir, answer.
Answer is D. Let us see. How do you arrive at D as the answer? First of all, how did you come about it, Mister?
So I found out reaction at A.
What is the reaction at A?
It's minus 20.
Very good.
Downward direction.
Downward direction. This is minus 20. So it is direction is minus 20. Now you can do it. Others.
Oh, then
yeah, fine. I got your way. Okay. Don't worry. Others. That's the correct way. Okay. I'm not sure which is the answer. We will see. We will go and see the answer. Okay. Yeah. What about others? So here you see you can go directly. Here it's 4 into 20. So 80. 80 is the answer. So that's it. D is the answer. Simple and straight. Correct. So on one side, if you take the bending moment, that's more than enough. So it is 20 into this one. It is minus, negative, downwards. Correct. So it is minus 20 into this. So by seeing the question only, you will be able to answer if you have proper practice, students. Okay. It's more and more practice, you will be better. Okay. So let us see what is the answer for this. It has come in 2015. Okay. Solid mechanics 2016. This is 2015. Yes. 2015 question number 11, right? So this is of 2000 this is 2016. I'm sorry. So 2015 question number 11 we will go. So we'll go to old gate question papers. Old question papers, and then XC 2015 answer keys. This is the same thing. I'm sorry. So is this 2016? Okay, fine. Yes, the answer is D. Correct, students? Simple, easy, fine. So let us stop it here. Any other doubts you have, you can ask me, students. Oh, wait a minute, let me not stop. Okay, let me continue it a bit more. Whatever I have planned, I have done it now. Okay, so it's okay. We will meet again at 9 o'clock. Okay, next time I will put more questions, because if the students are fast enough, I'll put more questions. The questions what I have thought was less. Okay, so we will do it at 9 p.m. We'll meet again, students. Okay, and tomorrow I'll give you much more questions on SFD BMD. Okay, fine. Thank you very much.